The Client Utility project has a very simple goal. We just want you to change the way you think about computing. Today, people think about computing as a set of hardware you buy and the software you install on it. With the Client Utility, we want you to think of computing as a set of services that you use as you need them. And so as I go through this demo, I'm going to continually talking about this being a service, that being a service, and that's because that's the way we want you to think about computing. Now, what we have in here is our lab that we set up originally to test our ideas, and we've built a number of demos, sample uses of our ideas on top of it. The important thing to remember here is that although I'm going to be showing a lot of different things, there's no special cases, there's no point solution. We didn't say, oh, we're going to show printing, so we got to add this mechanism, or we're going to show remote use of a Windows file, we're going to add that mechanism. We set our small set of abstractions in place, and this was just to test them. And so far we haven't had to add anything to them. They've held up very well. So let me start by explaining what we have in the lab here. We have a couple of Unix machines, and this machine is connected to that machine. Now, these machines are on a local Ethernet, so what does it mean when I say connected? In fact, it means that they've connected with the Client Utility Protocol, which means that they have each told the other what resources, like files and programs, they'll let users on the other machine use. And so whenever I talk about machines being connected, that's what I mean. We also have an X station we're using as a management console. I'll show you more of that later. We have two NT machines that will be providing NT services. We have a laptop, and we're just using this big screen to make it easier to see what's going on. We've got a 386 with a couple of megabytes of memory. We've got a Palm Top and another Unix machine. In addition, we have some printers in the room and some other computers scattered around. So let's get started with the demo. So let's assume that this is your computer, and you have just walked in and handed it to me and said, I want to print this file. So I'm going to come in here and hook it back up. Let me get this big screen hooked in because it's easier to see. Okay. Now, if you came in here and said print, you see the print come down here, what do you think the machine's going to do? Well, it's going to laugh at you. You don't know anything about our printing environment. You don't know what printers, what servers, nothing about it. In fact, we've configured this machine with no print drivers installed. There's no way you can print. Now, the reason you have a problem there is you have to tell the system how to do the print job. You have to say, print on this printer that has that particular name, with that server that has that particular name, rear drawer, color, all kinds of stuff. If you start thinking about printing as a service, what you're going to do is you're going to describe what job you want done and let the utility figure out how best to do that job on your behalf. Now, we could have put this particular menu behind the print menu that we just saw, but for the purpose of the demo, we want it to be separate. So what we're doing here is we've got a print job ticket. We're going to say what job we want done. We want to print locally. Right now, we've defined local to be in this demo cube. We want to print that file, and we want to print in color. We could put other things on here as well, but this will suffice for the purpose of the demo. Now, when I say OK, what's going to happen is the client utility will see this request as a request for a service, and it will look in its repository of information and say, who knows how to print a Word document? And what it will find is nobody, but it does find a local print service. So it goes to the print service and says, please print this Word document for me. And the print service says, yes, I know how to do that, but in fact, in this installation, we have to do it in two steps. First, we have to render from doc to PCL, and then we have to print the PCL. So if we look over here, what happened is the print service went out for a service that says render doc to PCL, and two machines bid. In this case, they're bidding their system load, and by picking the least heavily loaded machine, we find we get a pretty good job of stochastic load balancing. Right? Eventually, you know, if you have enough machines, the load balancing will be pretty good. It's not optimal in any sense. And this takes about a minute. In fact, we can see over here that this is the machine that got the print job request. And that's going to finish momentarily. And in fact, it just finished. And now the print utility is going to go out to the printers and says, who's willing to print a PCL file in color for me? And one of the printers has answered. And it turns out it's this printer up here. And momentarily, we're going to get paper coming out. Now there it comes. You can see the light flashing and the paper is coming out. There we go. Okay, so that's interesting. What if I want to do it again? So I'm going to come over here and I'm going to do the exact same thing I did before. I'm going to print locally. I'm going to print the same file. I'm going to print it in color again. Okay? Now we're done. We don't remember that you just did this. So when you say print, we go look for somebody who's willing to print a Word document. Maybe that service came along in the interim. It makes sense to check. We don't find it. We go to the print service. Look what the print service does here. It went out and it says, who's willing to render doc to PCL? And the same two machines answered, but one of them bid 1. Why did he bid 1? He bid 1 because it was already in his render cache. He had previously rendered that. So if we're working in a distribute and print environment, we don't have to render the job every time, which is a lot of computation. You notice how much faster it printed. We've already got that paper out of the printer. So if we're in a distribute and print environment, as long as there is a machine in the utility that has a pre-rendered version of this particular document, we don't have to render it again. It just becomes a service. And by picking the low bidder, we know that we bid low when it's in our render cache. Okay, so that's one aspect. Here's another aspect. I'm going to open up another file here. Now this is a confidential file. Maybe this is a flame against my boss, or it's the financials on my way out to the analyst meeting. So now I'm going to go over here and I'm going to do the same thing I did before. I'm going to select print. I'm going to print locally, file name. I'll do this one in black and white. Okay, now the same thing's going to happen. Nobody does doc directly. We've pre-rendered them, so there's no speed this thing up a little bit. But we got two machines to do the rendering, and then we're going to go out for print. And in this case, 2 printers bid, because we've configured both printers to accept black and white jobs. Okay, and the paper will be coming out on that upper printer. You see the lights flashing up there. And it turns out it's a very slow printer, so it'll take a long time. But eventually, paper will come out. Well, why is this interesting? Well, this is a confidential job. Let's say in the middle of the night the sysadmin comes in and says, the printer in the lobby is broken. We've got to have a printer in the lobby or all our guests get lost because we can't give them a map. So he takes one of these printers and he moves it to the lobby. Okay? And he sends out email to everybody. He says, don't print confidential stuff on that printer because, you know, it's in the lobby. You're going to be in trouble. And I don't care how much you encrypt when you print on that printer. If somebody's looking over your shoulder when the financials come out, the SEC is going to be on your tail. So you better not print on that. Now, in the client utility, the sysadmin does one additional thing. He comes over to the administration console. He finds that printer and he changes it. And he says, this is no longer a secure printer. This is an open printer. That's it, okay? Now, morning comes. I know this is hard for you to believe, but I come into my office and I don't read my email first. I know it would never actually happen, but bear with me. And I come in here and I go print. I do the exact same thing I just did. Print locally, this file name, print in black and white. Okay, and now the client utility does the same thing, but when it comes time for the print service to ask who can print the job, there's only one machine because the admin moved the print server out to the lobby as well, and there's only one printer that has the right security level to do the bidding. So the interesting thing here is that I, as the user, know the security level of my file. The owner of the equipment knows the security level of the equipment, and the client utility understands the security rules and will enforce the policies automatically, will not allow security mismatches to occur. Okay. So that's part of printing. Now, I've shown you a lot of printing, and I'm going to show you a little more, but the whole idea is that this could be any kind of a task, and we're just thinking of it in terms of being a service. So here's another example. Someone has given you a URL, and you want to print the document that's behind that URL. Now, you don't know what's back there. It could be HTML, could be PDF, could be PostScript, could be some proprietary format. You don't know. So what you're going to do is you're going to come over here and you're going to say, print this job. Okay? Now, the client utility will see this request. The browser will fetch the file, find out its PostScript, will go to its cache, its repository of information, its cache of information, say who's willing to print PostScript, and there's nobody. And you're going to find that there's a local print service, and he goes to the local print service and says, who's willing to do, will you print this PostScript file for me? And the print service looks in its repository and finds nothing that understands PostScript and says, sorry, Charlie, you're out of luck. And that's what this message says. Now, what I'm going to do is I'm going to get up and untangle my wire here. And I'm just going to walk around. And I'm still tangled, so I got to go back just a minute. Bear with me. I'm just going to walk around over here.
Go ahead.
Are we fading in? We're all set? Okay. So we just had a camera glitch. The cameraman tripped on the power cord. Those kinds of things happen. Okay. So what I'm going to do here is I'm just going to plug in a printer. Now this is a PostScript-enabled printer. And now I'm going to go back, and with any luck we won't trip on the power cord again. And what we see on this screen, well, we see some interesting things. First of all, this machine has reported to the operator that it's overloaded. We've set some thresholds, and so we have the ability in the client utility to keep track of what's going on. And in this case, we've warned that there's a potential overload going on this system. But what I want to show you is right here, when I plugged in that printer, when it started to come up in the network, it noticed that it was in the utility and started bringing up its utility information and connecting in. Now, the machine over here previously registered that it was interested in PostScript files, so the printer knew that he should inform that machine that there's now a PostScript printer available. Another interesting aspect is, in a very large utility, we can't rely on the information being consistent at all times. If you require consistent information, you give up all performance because every change has to propagate through the whole system. In the client utility, we assume that any piece of information we have could very well be out of date, could be stale data. And here's an example. If you can read this on the screen, that printer has reported that it's connected to nobody. Now, in fact, I know, because I've run this demo before, that it has connected to the machine that it's supposed to. But we just have to deal with that kind of information, and we'll see other examples where we deal with out-of-date information. So now I'm going to come back over to this machine, and then go back to the previous page, and I'm going to do exactly what I did before. I'm just going to say print. We go into the local repository, we say I want to print a PostScript file, who will do it, and now because that printer is connected to us, we find out that it's that printer. That printer is now rendering this document, and momentarily it will tell me the document printed okay, and then we see the light flashing on the printer. We're not going to turn the camera on it, but if the microphone's working properly, you can hear paper coming out on the printer. All right, so again, those are some examples using printing, but when you start thinking about computing as services, what just happened? I plugged in a new device. That became a service that users could discover. I didn't have to tell 400 people that there was a new printer. I didn't have to install drivers on 400 machines. As long as there was one machine out there with the right driver that was willing to provide the service to those people who used it, they could get advantage of the printer. And in fact, I can unplug that printer and plug in a new model, and everybody just gets better service. So as soon as computing becomes a service, you get this dynamic discovery and upgradability of the services available. Okay, as long as we're talking about service, let me show you something else. Let's say, here's the HP Services page. This is a place where HP ISVs can advertise their service. And let's say I want to create a new service. So, I am a manufacturer, let's say, of little red wagons. Now, what do I do as a manufacturer of little red wagons? Well, I'll go out and I'll get bids on wheels and handles and bodies, right? And then I'll select a vendor for each of them. I'll place my orders. The parts will come in. I'll assemble the components, make a little red wagon, and take it down to Toys R Us and sell it. That's the way we do it in manufacturing. Now, I would like to do that with services. Let's say that I know that there are people out there willing to do payroll for me, and people out there willing to do tax preparation, And of course, after taxes, there's no money left, so we don't have to worry about cash management, but let's just say that there is cash management services out there. And what I would like to do is make a new business called Integrated Financial Management. So what I do is I go to HP and I fill out all the paperwork, you know, I say I'm a good guy, I'm not going to cheat anybody, and they give me access to this web page over here. Okay. Now this is the web page where I create new services. So I come in here and I say, okay, what do I want to call my service? I want to call it Finances. And how do I want it advertised? We'll call it Financial Services. And where do people come to sign on as customers? And I give that. Any special security requirements. And now all I do is I compose my new service out of existing services. In this case, it's a very simple linear workflow. I go from payroll, and I say what service gets invoked, and what the inputs and output are, and I go to tax preparation, and that's basic, and that's all I'm going to do here. Again, there's no cash left over. All right. So what I do is, this is the way I would invoke the service myself if I were going to do it. So now I'm going to compose a new service called Finances that will invoke first this service, then that service, and each time we're going to go out for bids and find the best provider. And now I come and I create the service, and as soon as the service is created, people who access this HP Services page, I'll wait for the camera to catch up, okay, we'll now see my new service advertised. It becomes a discoverable service. Okay? What was my added value? Here I can go ahead and just start signing up customers. What was my added value? Maybe it was just a unified interface for these two disparate services. Maybe it wasn't even that. But the point is that if computing is a service, I get composability. All right, if I have a million machine utility, it's going to be a little awkward to call everyone and tell them to shut down their machine at midnight on Sunday because we got to upgrade the software. So we have to be able to do rolling updates. And what I'm going to show you now is exactly that. So I'm going to go over to this machine that we did before, and I'm going to shut it down. Okay, so I'll close my application. Now what I'm doing is I'm gently removing this machine from the utility. So now at this point, the machine is not in the utility. Nobody can use the services that were originally provided by this machine. And I'm going to come over here and I'm going to shut the machine down. Okay? And we'll shut down the computer. Okay? And then I'm going to do an upgrade. And in fact, I'm actually going to do a hard reboot just to make sure. We've had a little hardware glitch on this machine, so I'm going to actually give a little poke with the pen. And now what I'm going to do is I'm going to upgrade both the operating system and the version of the client utility software. So I am upgrading from NT 4.0 to NT 3.5.1. I consider that to be an upgrade. Some people agree with me, so that's what we're going to do. Okay? And then I'm also going to change the client utility software. Now, what we have done is we've actually configured this partition so that it knows nothing of the client utility. So as soon as this machine boots up, it has no information of the client utility. So what I'm going to show you, we could also do if we had just bought a brand new machine and we wanted to install it in the utility. Now also, what I'm going to show you could be done by an administrator from a central console using a script. It doesn't have to be done, I can't type my password. It doesn't have to be done on each machine individually. All right, so here we are, and what I'm going to do is I'm going to bring up a standard browser. Let me bring back the screen so we can now look at the real screen. Might make it a little easier to see. And there it comes, a little energy conservation in the works. And I happen to have a bookmark. You wouldn't have a bookmark with a new machine. Well, maybe you would. You have a contract with Netscape. All right, now what I'm going to do here is I am going to click on here and download all the software, all the configuration files needed to bring a machine into the client utility. I'm not going to bring down any of the drivers, the display drivers, the file systems. They're big. But watch closely. Don't blink. We're done. That's it. And I don't even have to reboot. Okay? Now at this point, I am ready to join the utility and use the resources that are there. Okay? And that's all I have to do. I can just start the utility and off I go. But let's say that I have a new service. Let's say there are people out there providing a service and I decide I can make money by underselling them. So I have a new service I want to provide. So I can go over here and I can configure it. And this is what we're going to do. I'm going to configure it, and the service I'm going to provide is a very interesting service. It's called Free Cell. Okay, it's a game, big deal. I'm going to make it available to others and people on my machine, and then I'm going to save it. Now I could do this for additional services, but let's say I'm done at this point. And that's it. That's all I have to do. Now I am ready to sell my service into the utility, and I can join the utility. And let's see here. Good. Okay. Now I'm using a different version of the operating system than before, a different version of the client utility software than before. Okay? And it doesn't matter. One of the fundamental things we've done in the client utility is we never make an attempt to look inside another machine. Okay? So, for example, I don't care what you call a user on your machine. On my home machine, I'm the daddy. I'm going to pay the bill. You have the contract with me. Yes, you'll tell me it was Joey who just spent $20 on dirty pictures so I can tan his hide, but that's my business, not yours. And that's very important, that you don't have to worry about what I call a user. Okay? Let me bring this machine in to the utility. Okay? Okay, now this machine is coming up in the utility. Right? And it'll take a few seconds, so let's just go over here and do something else in the meanwhile. Here is a Unix user, and he has previously done a what's new. What's new says what services are available that I haven't previously asked about. And he gets this short list. At the time he did it, he got that short list. But meanwhile, more machines have joined the utility and there are more services available. So he says update that display, and now all of a sudden we get additional services that are available. Now we're showing the machine boundaries. That's just for the purpose of the demo. Normally you just show them as services. And if we go down here, you'll notice that we also see this free cell that I just exported from the other machine. So that's how easy it is to become competitive in this marketplace. So now when I go to run free cell, that guy can bid on the request, and if he underbids the competition, he can make a lot of money. Okay? And I, as a consumer, am very happy because I've got a more competitive marketplace. Now, one of the things I see here is WinWord. Now, I am a Unix user, but I may be collaborating with a PC user on a Unix document. So what I'm going to do up here is I am going to type /WinWord, and the client utility is going to see this, and it's going to go and say, okay, who's willing to run WinWord on my behalf? It's going to look in its repository, its cache of information, and it's going to see that it's those two machines over there. Okay? Now, those two machines are going to bid on the business. This guy bid $1 an hour at 1 second response time. That guy bid $1 an hour at 1 second response time and 50 frequent flyer miles, so he gets the business. I'm running a Microsoft app, so I get the business, but we'll let that go for now. At any rate, and he's going to bring up Microsoft Word for me. But some magic has happened here, because I, as the Unix user, said /WinWord, but that's meaningless to an NT machine. He wants to see C:\WinWord. So what happened here? Well, the client utility virtualizes all names. If you and I have a conversation, and you say my house and I say my house, we have no problem understanding what we're talking about. On the other hand, if you sit down at my computer today and say my house, you get a picture of my residence, not yours. In the client utility, wherever you go in the world, as soon as we know it's you, when you say my house, you get a picture of your residence. In other words, your namespace is global. It goes with you wherever you are, but it's personal. It's local to you. Now that's important for people, but it's even more important for applications. Because the reason I don't run my application on someone else's machine when he's on vacation is that program won't be able to find its stuff unless we've agreed to put all our files in the exact same place. But if the names are virtual, when I move to his machine, I take that namespace with me and just change the mappings out from underneath me. This is a real problem that is underestimated in developing distributed systems, and I think we've done a very good job with this. Well, at any rate, here's Microsoft Word. It's come up, and I can begin to use it. And I will open my file. And here it is. And if you remember the beginning of the demo, this document should look reasonably familiar to you. Okay? And this is live. I mean, I can do my thing here, right? Now, it's actually running on a machine over there. It's actually running on an NT machine, but it's mine and I can work with it. Okay? So that's very nice. That's a nice service. Okay? But now it's time to go home. So I get up from my desk and I go home, eat dinner, wash the dishes. In my house, I wash the dishes. It's better than eating my cooking. And after I get the dishes done, my kid's in the back bedroom playing Frogger on the 386 that we have back there. It's not his bedtime, but I want to use the computer, so I send him to bed. Dad, come on, Dad. Go to bed, go to bed. All right. So here's a 386 with a couple megabytes of memory. Now, it can't run Unix, it can't run NT, it can't run Word 97, but I can come in here and authenticate myself to the system, grab my session, and there it is. Unix, NT, the whole session is here, and it's live. I can do my thing. Right? I can do anything I need to do in NT, and off I go. If the display's a little slow, you can imagine how difficult it is to find a display board for a 386 these days. And if you look back over here at the other machine, the session is gone. In other words, I've taken it from that desktop and I've moved it to this desktop. Okay? So let's say I'm working here, and after a while I decide I need some help. So I call the support desk and I say, help. And they say, what's your problem? And I tell them, I say, okay, we can help you. Share your session with us. So I come over here and I select share, and I say, what's the magic authentication sequence? And they tell me. Okay. And now it's in both places. So they can come over, they can work over here and say, for example, format. And the same thing happens over there. And I can come back to this machine and I can say view, and the same thing happens over there. So we're sharing the desktop. Okay? It's very nice. Then it doesn't have to be just two ways. We can do it n ways. So the next time you have to write your department mission statement, everybody can put this window up on their screen and contribute exactly one word, which is what you do when you write a mission statement anyway. All right. So now they say, are you done with the help? Do you need any more help? And we say no. I say, okay, we're going to detach and go help the next guy. And they do. Notice we got the warning pop up again. Another machine, actually the same machine this time, is overloaded again. We better do something about that. And now I can come back here. I'm back. I'm still at home, remember. I'm still at home working. Okay? And I can continue to work. Okay? No problem. Okay. Now it's time for me to go to the airport. The limo's in the driveway, the driver's honking the horn, and what do? I say, detach. And now where's my session? Nothing up my sleeve. I'm wearing short sleeves, right? Where's the session? It's just in the utility. It's just in the utility. So when I get on the airplane, I plug my Palm Top into the airplane utility, authenticate myself, and grab my session. And there it is. I have all my stuff that I have. The whole desktop is there. The Unix, the NT, everything. Okay? And when I get to my hotel room, there's a computer on the desk, and it's got one of these little boxes on it. And I authenticate myself. And I can grab my session. And off I go. And when I was disconnected, when the session wasn't there, the applications didn't even know I was gone. If that was a big spreadsheet calculation, it kept right on calculating. Okay? So that's one of the things. I'm just getting my list of things so I don't forget anything to show you here. So again, the client utility understands the security level of these windows. And so when I'm in the hotel room, the hotel computer doesn't have sufficient security. Maybe this is a very confidential document, right? It's corporate plans, marketing plans, some ad program we're just about to run, we don't want to release. And if that security level is too high for the security level of the computer on which it's being displayed, the client utility understands that, and the window won't even show up. So you can't accidentally expose something. Now, if this is the corporate CEO sitting in that hotel room, he says, I need that data, he can authenticate himself to the system, raise the security level of this machine temporarily, and then the window will appear. So we also have to provide for that. All right, here's another aspect of what happens when you start to think of computing as a service. Here's a guy on a Unix box, and if you remember at the beginning of the demo when we started all this, I said that he was connected just to this other Unix box. So he knows nothing about NT. Nobody knows anything directly about NT. And if he wants to run FreeCell, that game we talked about, and he says, okay, what happens is it says, looks in the repository, looks in the cache of information, who's willing to run FreeCell on my behalf, doesn't find anybody. This particular user's policy is just give me an error at that point. I don't need to know anymore. He doesn't want to have to go off into the network for every typo. Now, the interesting thing here is that this other machine has agreed to be a broker for this machine. So instead, what I type now, and again we could hide this behind that first command, is I type do for me /FreeCell. The client utility looks in the repository, says who's willing to run do for me. That machine is. I say please run do for me on my behalf. He goes out and runs do for me. What does he do? He says who's going to run FreeCell on my behalf. He goes out and gets the bids, they come back, and eventually FreeCell is going to appear on my screen. In fact, this machine over here is got the winning bid. Now, think about what's happened here. This is a level of privacy that you don't get from encryption. A lot of times people are not interested so much in the contents of what you're seeing as they are in the fact that you're seeing it. So in this case, I'm not going to get on any games mailing list from that guy just because I'm playing the game. There are a couple of other advantages. Here's the game. We might as well start one as long as it's up. Okay. You see, I can play the game. It's really running over there, passing through the broker to me. The broker's happy. His business is protected, right? We don't know who we are. As far as I know, I'm buying FreeCell from him. As far as this guy knows, he's selling FreeCell to him. The broker's business is protected. He doesn't have to worry about being cut out. Now, in an enterprise, of course, he could introduce us, and then we could talk directly. But if he wants to continue to be the broker, he can choose to continue to be the broker. I'm not going to get any games mailing list, and furthermore, I didn't have to give my credit card number to some 12-year-old over here who might be selling FreeCell, right? I'm dealing with the broker. The seller of the game, on the other hand, at the end of the month gets one check from the broker. That means his per transaction cost just went from $1 down to a nickel. So everybody's happy in this situation. Everybody works out very well. All right, now, computing is a service, right? That means I'm being provided the service. I don't really care, but most of the time, where that service is coming from. So what I want to show you now is how we get reliability out of this idea, out of the utility. So we've got Microsoft Word. I happen to know, because I'm sitting in the room and I could hear the disk spin, that Microsoft Word is running on this machine. Now what I'm going to do over here is I'm going to trip on the power cord. Actually, I'm just going to hit the power switch. Now that is a very nasty failure. If this was a distributed operating system, it'd take us quite a while to figure out what's going on. Now what we see here is that FreeCell is still working, but Word is dead. He doesn't know it yet, but he's dead. Okay? Now, what would I do if I had this failure on my own PC at home? Well, after rebooting, of course, I type the command again. Now here's another example of where we're dealing with out-of-date information. I just said restart the application. And we're going to go out, look in the repository, find the cache of information, find out that there are two potential providers of this particular service, ask them to bid. But not surprisingly, dead men don't wear plaid and dead computers don't bid for services. So in fact, even though I don't know that that machine's dead, it doesn't matter. Every piece of information is potentially out of date and we just deal with it. In this case, we deal with it. That machine gets the business, and momentarily we're going to have Microsoft Word coming up on this screen. So what we've done is we got reliability from the multiplicity of service providers. Okay? What about my data file? Well, remember we said that every resource, every file has a name, a logical name. There comes word. Every resource has a logical name and a physical name. I can come over here and I can actually open this. Oops, sorry. I hate that little paperclip guy, but we live with things like that all the time. Now I can open my file and continue my work. How can I do that? Well, remember we said that every file, every resource in fact, has a logical name and a physical name. Clearly the physical name tells you where to go get it. But what rule says that there can only be one physical name? Let's say I have two physical names. So when I name this file and I read from either one of them, and when I write to both. So I get mirroring. I get file mirroring just for free, just because of the way we do the naming. And so all we need is to have at least one service provider of the application and at least one service provider of the file still available, and I can get access to my file and I continue working. So this is even a better failure model than you get off of a single machine. Now, we understand that in the world today, there are bad people trying to do bad things. And people spend a lot of time worrying about hackers. In fact, 80% of the problems on corporate networks are caused by insiders, not hackers. So even for people within your enterprise, it's important to control what they can do. Okay. So what we can do is we can actually control what the names that any user can see. So here's a case. Where this user, this is just a little simple pop-up that shows you what the directory looks like. This user right now in the directory /users only has access to one file demo. And if he asks for another name like users GJR, he's told it doesn't exist. And if he tries to guess the name by creating users GJR, he's told, okay, it gets created and it's given a different physical name. No problem. So you can't even guess the names by trying to create them. There's no way here. And if you don't have a name for something, you can't attack it. You can't say erase. So if an attack is inexpressible, we don't have to worry about it happening. But what if he needs that access to that resource? Well, I've just written a little script. All he says is give me Bill's files, and here's the magic password, and now he has access to the file. But the system administrator can come over here, find that user, say, I don't want him to have access to that file anymore. This is a list of all the things that this guy can name. And if he comes down here, finds users GJR, and says delete, that name is no longer available to this user. So security is very tight in the client utility. We believe it enhances the security of any existing system. Welcome back. You may notice that I've changed my shirt and gotten a haircut. What happened was there were a couple of things we left out of the original video, the demo, and we wanted to show them to you. And those are the management interface and my beeper story. The actual user interface we have for the management console is not so interesting, but the fact that we can record all kinds of useful information is, and we want to show you that. As for the beeper story, you're just going to have to wait until I get to it to find out what it's all about. What I'm going to do now is I'm going to go over to another machine and do something. And what's going to happen there is it's going to cause that machine to be overloaded as far as the administrator of the utility is concerned. And we want to show you that we got a pop-up, a warning that this machine is now overloaded, and the operator can take some action. In addition, on the management console, just get that out of the way, we also have the ability to monitor everything that's going on the machine. So we can see here that we have all the processes that are going on. We can monitor how many copies of each application are currently being used, and we can keep track of that for license management purposes. We also monitor network delays. Every time we contact another machine, we record the network delays. In this case, even though we've contacted another machine, the information hasn't been posted yet. And as we said before, the client utility is built to deal with out-of-date information. So even if we expect to have some network delays reported and they're not posted yet, we can deal with that very easily. So that's a little bit about what the management console has. I can also call up the interface that shows us all the resources available to any particular user. And for any particular resource, I can modify it in place. I can delete it from this user's protection domain so it's no longer available. I can add things to the protection domain, all from the management interface. And that's about all we have to say about the management interface. Well, now let's talk about my beeper. Here's my beeper. What I'd like to be able to do is have somebody access my calendar file and beep me for my next meeting. With the client utility, I can just make that a service. Someone gets permission to read my calendar file, and then that person can dial my beeper and beep me for my next meeting. That's something we can do without making any modification to the beeper. But to me, one of the most interesting things that's come out of the client utility project is our new architecture. What you saw in the demo was a first cut. We went ahead and we understood, we learned what we'd done right and what we'd done wrong, and we re-architected, and in the process came up with something that to me is very exciting. Let's say I wanted my beeper to do this itself, beep me for my next meeting itself, not use an external service. And what I'm going to do is I'm going to run the client utility on here. You see, if I wanted to do that today, I'd have to have an operating system like VxWorks or Windows CE or NT 5.0 running on the beeper. And all of those are pretty heavyweight for a beeper. They know about files and processes and memory and all kinds of stuff that the beeper really doesn't need to know about. But if the client utility is the operating system on here, what it knows about is 5 resources. 3 buttons, a display, and something that goes beep in the night. Every once in a while it goes a beep in the night and it's pretty annoying, but that's all it needs to know about. And now there's an application on the beeper that said downloads Karp's calendar file. And the client utility code says file. I never heard of anything called a file, go away. And the application goes away. At some later date, I come over here and I connect to my home machine by some means, maybe an infrared link, for example. And we go through the client utility protocol, and the component on the personal computer tells the component on the beeper, you may read Karp's calendar file. And the component on the beeper tells the client utility code, whenever you hear about anything called a file, you ask me, I know what to do. Now that application wakes up and says download Karp's calendar file. Ask the client utility operating system, which says file, oh, I know who to ask, I'll ask that guy. Well, this guy doesn't know a thing about a file, but he knows who to ask. Once the request gets over here, we're on a real operating system with a real file system. The bits get read, they get sent over the link to the beeper, and I get beeped for my next meeting. Now think about what's just happened. We now have an operating system running that can deal with a resource type that was invented after it started running. I don't have to wait for a new release of the OS. I don't have to wait even to reboot. It just deals with the resource type. To me, that's one of the most exciting parts of the client utility project.